Okay, for this problem, we're talking about fruit. And they tell us that the population of fruit weights is normally distributed. So we know that we're normally distributed for the population. And they told us that the mean for the population is 268. The standard deviation for the population is 28 grams. And we're going to take a sample size of 16. So as long as we know that the population of fruit weights is normally distributed, we can do this problem. So we have to figure out what our mean for our samples. It's equal to the population mean, which is equal to 268. And then our standard deviation for our samples is equal to the population one divided by the square root n. So that's going to be 28 divided by the square root of 16, which is 28 divided by 4, which is 7. Okay, so then I draw my picture and smack them down the middle. That's my mu x bar, which is the 268. We wanted to know, okay, the question says 9% of the time their mean weight will be greater than how many grams? So basically, we want to know what value, what mean a weight for a sample of 16 will 9% of the time be greater than this value. So basically what they're saying is this over here is 9% area. There's a 9% area. So 91% would be less than this weight, and 9% would be be greater than this weight. So it's like, think about it, if you took a sample of 16 over and over and over and over again, what value will 91% be less and 9% be greater? Okay, that's basically how you can think of it. So because this is 0.09 over here, the whole area is 1. So this area over here is 1 minus 0.09, which is 0.91. So this area is 0.91. Don't know what x bar is. When you know the area and you want to find the value that goes with it, I think that's when we have to whip up that table that I gave you, right? But the table that I gave you deals with z's. So let's deal with z's first. So right down the middle, z equals 0, right? We know we want to find the z. We don't know what this z is, but we know that this area is 0.91 to the left. So let's figure out what that z is. We're 0.91 to the left. We know the area to the left. So we take the table out and we go, well, I know z is positive because z is to the right of 0, right? So we know we got a positive z. So you're going to go to the positive side of your table. And you know the area, you know the probability. So you're going to look for 0.91 in the body of the table. You're not going to look up 0.91. That's a z. We don't know the z. We're trying to find the z. So we're going to look for the closest thing we can find to 0.91 in the body. So I start looking. Oh, let's see. Oh, right here. I see 0.9099. That's really close to 0.91. So it's right here. I don't know if you can see it. So I go across. You can look at your table. And I think it's 1.34. So from the table, you look for 0.91 in the body, right? And we got our z is equal to 1.34. You look for 0.91 in the body, closest thing you could, and it corresponded to a z of 1.94. 1.94 is not a weight in grams. We have the z. Now we got to convert that z over to like an x. Remember, we did that before. So our formula is for converting, right? That's our z formula. So we know the z. That's what we looked up in the chart, 1.34. We don't know what that x bar is. That's what we're trying to find. We know the mu x bar is 268. And we know the sigma x bar was 7.
Okay, so we cross multiply.
7 times 1.34 is 9.38 equals x bar minus 268.
Add 268 to both sides, right, to get x bar by itself.
And you get an x bar is equal to 277.
Okay, so there were quite a few steps. First of all, you had to figure out what your mu x bar and your sigma x bar were. You had to figure out what the percentage meant, that 9% were greater, so 91% were less. And we figured out, well, I can find a z that corresponds to that from our table. So we found the z that corresponded to 0.91% less. It was 1.34. And once we have the z, we had to convert it to an x bar by using the z formula. So there's a lot of steps to that. So hopefully go through this nice and slow and you'll be able to do this problem. I hope that helps.